In this video, we're going to work example problems where we simplify complex or also known as compound fractions. Okay, so remember the meaning of a compound fraction is just that. So you've got some fraction, you have a fraction bar here, and as we know, there's a numerator and there's a denominator. If you've got just one fraction in either the numerator or the denominator, then you call it a compound or complex fraction. It has nothing to do with that it has to, the fraction has to have a variable term in the denominator, or it has some sort of restriction on it. No, across the board, that's it. Any fraction like this is a compound fraction. Or like, it's not like it just has to have these like rational terms with x to the minus 1. No, this is a compound fraction. Okay. Now, but I also mentioned how, so I gave you guys an informal definition of what a rational expression means, and I think that informal definition is going to be really useful for you, as opposed to the more mathematically correct one, which would consider the number just 1. This is a rational expression technically. Okay, so but the informal definition I think is going to be really useful for you, but I think this is the only circumstance where the informal definition doesn't work, because the informal definitions would say that this is a rational expression. Okay, but this isn't really a ratio of polynomials. This is 27x to the minus 1 plus 1/9 over 1/3 plus 9x to the minus 1. So yeah, we only have powers of, you could do it like, so you could do this 1 over 27 right? So we only have, like, the idea was with the informal definition, you go look for all the different variables and you see, okay, are there any that have a negative integer power, but also there's no radicals or logarithms or anything like that? And if you find at least one variable that does, then, it's a rational expression. Well, this meets that criteria. But this is a little bit different, right? I wouldn't, going by the technical definition of a rational expression, the technical mathematical definition being a ratio of polynomials, well, this certainly isn't a ratio of polynomials. So when it comes to the way you need to look at it is that I think this is the only exception where the informal definition won't work. And so if you happen to have a compound or complex fraction, then you want to look at that as, okay, it's a compound fraction that's a ratio of what type of expression to what type of expression. Here we've got a compound fraction that's a ratio of a rational expression to another rational expression. Or if you had, x to the minus 1 plus 3 over x squared, this would be a compound fraction because, right, it is a compound fraction that's a ratio of a rational expression to a polynomial. That's the idea. That's how you want to approach it. Okay, so how do you simplify compound fractions? Well, there's two methods. There's like the order of operations method, and then there's the least common denominator method. I like the least common denominator method, but you could do whatever you want. The order of operations method is just going to say that you want to do this addition here and get one fraction, and then do this addition here and get one fraction. Then you can like multiply those fractions. You could take the reciprocal of the denominator and multiply them. Then you can like just do the division of two fractions where you take the reciprocal of the denominator and you multiply it. Okay. Now, but the least common denominator method is going to say that you want to multiply this entire compound fraction by 1 in the form of the least common denominator of all of the fractions that are there. So in this case, we can see that would be, we want to multiply by 1 in the form of 27x over 27x. Okay, so what we're going to get is 1 plus, and then 9 times 3 is 27, so 3x, and then in the denominator, we're going to get 9x plus 3. Which, let's put that as 3 plus 9x. Okay, now but we can factor out a 3 from the denominator. And we can see now we have these two 1 plus 3x's, so we're left with 1/3. Now this is kind of weird because like we still are going to put next to this 1/3 that x can't be equal to, let's see, it would be 0 in this original expression. And then also we can't divide by 0 here, so x can't be minus 1/3 because then you have 1/3 minus 1/3. And that's the answer, which is really weird. Like we put that next to 1/3. Well, no, the idea is it's like if someone, here's the original model, if someone was inputting, you know, you're inputting the whatever the parameters are that go into this, right? But we simplify it to where we know whatever someone inputs, we're just going to put 1/3 no matter what. It's like a computer program. We're just going to output 1/3 no matter what they input. However, if they happen to input 0 or minus 1/3, we're not going to output 1/3. We're going to say they're given error. No, there's no answer here. Okay, let's just, I like the least common denominator method. I'm just gonna go ahead and use that. So we need to multiply by 1 in the form of 6x over 6x. So we're gonna get x squared minus, and then we have to do like that, right? Put the minus in front of everything. And then we're gonna get x minus 7. So x squared minus 5x minus 14 over x minus 7. So can we factor this? I think we can. So x 7, 2, minus 7 plus 2. Okay, so we're left with x plus 2. Okay, but x can't be 0. And x can't be, what else? Can't divide by 0, so, you know, whatever x would make this positive 1/6. So, okay, 7 over 6x is equal to 1/6. Cross multiply, so, yeah, x is equal to 7. So x can't be equal to 7 either. Okay, so we've got, let's see, 2 over a minus 1 over b, and then 4 over a squared. Okay. Least common denominator is going to be a squared, b squared. So let's multiply by 1 in the form of a squared, b squared over a squared, b squared. So we've got, let's see, 2ab squared minus a squared b, and then 4b squared minus a squared. There we go. Now we can just simplify like we did in the previous videos. This is just we're left with a rational expression here. So, okay, let's factor the numerator. So we could take out an a and a b, or a times b. So 2b minus a. Okay, now here we've got the difference of two squares, the difference of like 2b squared and a squared. So 2b plus a and 2b minus a. Okay, so we've got, let's do a plus 2b and then ab, and there we go. Now, but let's see. I mean, you can, like, a can't be 0, b can't be 0, and then you'd have to figure out what combination of a and b would make the denominator 0, but this is the simplified form. Okay, so there's only one fraction here, so we multiply by the denominator of that fraction, 1 in the form of the denominator of that fraction over the denominator of that fraction. So we've got 3 minus 3 times 1 plus h over h times 1 plus h. Okay, so 3 minus 3h over h times 1 plus h. So minus 6 minus 3h over h times 1 plus h. So, okay, let's just see if we factor out a 3 here. What do we get? 1 minus 1 plus h. So 1 minus 1 minus h. So we're left with minus 3h over h times 1 plus h. So minus 3 over 1 plus h. But we can see h can't be, h can't be 0 and h can't be negative 1. So h can't be 0, h can't be negative 1. Okay, least common denominator here is going to be x times x plus h. Okay, so we've got, let's see, 7x minus 7 times x plus h, and then over xh times x plus h. So, okay, 7x minus 7x minus 7h over xh times x plus h. 7x minus 7x is 0. So xh, okay, so minus 7 over x times x plus h. But let's see, x can't be equal to 0. X can't be equal to minus h. Okay. Okay, so let's see. This here, we can write this as, so x plus 1, x minus 1. Okay. All right, now here we can multiply by x plus 1 times x minus 1 over x plus 1 times x minus 1. And so we're left with 3 times x plus 1 minus x minus 1, and then all over 6. So 3x plus 3 minus x plus 1 over 6. Okay, 3x minus x is 2x. 3 plus 1 is 4. Okay, we can factor out a 2. Okay, so we're left with x plus 2 over 3. Okay, but x can't be equal to 1. X can't be equal to minus 1. We can see that from here.